Hello guys, welcome to my channel. In this lesson, we are going to learn how to simplify algebraic expressions. And here we're going to assume that the denominators here are non-zero, because if they are non-zero, you know that we'll have an undefined expression altogether. So we would assume that x and y are non-zero. All right, so let's go. So to solve this problem right here, we will just expand a to the x times y to the fifth power divided by x to the fourth power times y to the third power. And then we will now pay attention to the like variable, so x, and then also pay attention to this. But we know the rule that if you have x to the a, so these are all real numbers, and then divided by maybe x to the b, right? So what we do here is subtract their exponent. So it will be x to the a minus b. So we're going to apply this rule here to solve this problem or simplify that problem. So meaning that we can now do x to the 8 divided by x to the 4th. So x to the 8 divided by x to the 4th. Then we multiply all of that, or we can use times, and y to the 5th is divided by y to the third power. Okay, so what we can do now is to simplify each part. So which means x to the 8 minus 4. So I am now applying this rule here. And then times y to the 5 minus 3. So that simplifies to x to the fourth power times y to the second power. Again, this is going to be x to the fourth, y to the second. So just to get you ready for your ACT, this expression can also be written or simplified to x to the second power and y to the 1 power of all of that. So now, looking at this, it means that 2 multiplies 2 gives this 4. And y will raise to the second power, and it will exactly be the same expression. All right, let's go to number 2. For number 2 here, we have a denominator and a numerator all raised to the third power. So it will be 2 to the third power divided by x to the third and to the third power, something like that. Okay, so be careful now not to write 2 to the third power over x to the third power, because you have parentheses for both the numerator and the denominator. So you can make sure that you don't do this. All right, 2 to the third power means 2 times 2 times 2, not 2 times 3. So students may likely do 2 times 3 here, and they might get confused and do it at 6. Nope. So it's 2 times 2 times 2, which is 8. Divide that by x to the third power and to the third power. What that means is x to the third power times x to the third power times x to the third power. So 3 times, which means you end up adding, you have to add their exponents, okay? So which means x to the ninth power. So again, one quick way to do this is to just multiply their exponents. So it will be x to the what? 3 times 3, which is going to be 8 over x to the ninth power. So this is how you can do that. All right, let's keep going. Let's do some much more challenging problems. Okay, let's go to this example right here. For this example here, so what we're going to do is to kind of expand this expression so that we can see what we're dealing with. So let's go for the first numbers in the parentheses. So we have x, 4x to the third power, all to the squared. Yes, so let's just keep that separate from y to the fifth power. We're going to divide all of that by 8 times x, and x is just x to the 1 power, okay, times y to the negative 2. All right, again, to simplify further, I'm just going to work on this expression here. So what that means is 4 is to the second power, okay? So 4 is to the second power, and x to the third power is also to the second power. So that's what you do, because they're both in the parentheses, so they share the exponents. All right, so I am going to now multiply by y to the fifth power, and now divide by 8x to the 1 power. Make sure that I keep the multiplication sign different than y. So that's why it's very good. Sometimes you can use dots. Okay, so for example, I can use dots for multiplication and just vice versa. So what I have here will be 4 to the second power, and that's going to be 4 times 4, which is 16. Again, be careful not to do 4 times 2. Now, x to the third power to the second power, we'll just have to multiply their exponents, not addition. Okay, so it'll be times x to the sixth power times y to the fifth power, all of that divided by 8 times x to the power 1 times y to the negative 2. So what I'm trying to do here is making sure that I keep the like terms together, okay? So look what I'm doing. So I'm just making sure that x is to x and y is to y. And the numbers are to the numbers. So what I'm going to do here is to just do 8 divided by 16. So if 8 is divided by 16, I would get 2 out of that. So times. So I'm now going to go to the x variable. So what I'll do here is I'll do x to the 6 is divided by x to the 1. So which is just like keeping the same basis and subtracting their exponents. Okay, times, I'll use dots here if I want. So y to the 5th power and y to the negative 2 will be subtracted. So that's going to be, because I'm doing division, so it will be 5 minus negative 2. So this is what I end up with. So I'm going to have 2 times x, so 5, we have 6 minus 1, that'll be 5. And I have 5 minus negative 2 will end up as 5 plus 2. 5 plus 2. Because you have a minus sign and a negative sign. Yes, and that combines to positive 2. Again, 5 plus 2 will be 7. So I'm just going to wrap that up and write that down as positive 7. All right, so this is my final result, which means I end up with 2x to the 5th power and y to the 7th power. This is good. All right, let's go ahead and finish with the last problem here. All right, so what am I going to do here? So I have a negative exponent, but I will not worry too much. So I'm just going to apply the rules that if I have x to the 8th power, x to a times b is the same thing as x to what, ab. So this is the rule I am going to apply right now. So now I am going to take this negative 5 and multiply that with negative 4. So that means I'm looking at x to the negative 4 times negative 5, then times, I'm going to go to the y variable, it will y to the 3rd power times negative 5. All right, so divided by going to the denominator. So I have x to the negative 5 times negative 3. This is what I'm doing now. So I'm now multiplying by the exponents. So we have double exponents. That's what you do. Times, and I'm going to go to the y variable. I have 7, and I'm going to multiply that by negative 3. All right, so now let's go. So to be efficient, this is what you can do. So you can actually, there's a step that can lead to this, but then you're trying to be efficient. So you don't have time for too much details like that. So now negative 4 times negative 5 will lead to negative positive 20. Yes, two negatives always give positive. So now when you multiply them though. All right, so you get positive 20. So times, you have 3 times negative 5, that's going to give negative 15, and you're dividing by, now you have negative 5 times negative 3, that's going to give negative, times negative is positive, that's going to give positive 15. Then times, I have 7 times negative 3, positive times negative is negative, so I get y to negative 21. Cool. All right, we are almost done here. So now you can see what we're dealing with here. So here we're now having all the x variables together. Okay, this is what we're going to do. And then we're going to bring all the y variables together as well. This is what we're going to do. So, all right. So which means that this is going to lead us to x to 20. So since I have division, I'm just going to subtract their exponents. So minus 15. Then I go to the y variables. Again, combine the multiplication signs. Get y is to negative 15 minus negative 21. Again, because you're dividing, make sure you have your minus before the exponent and the denominator. All right, so again, this is going to lead us to x to the power of 20 minus 15 will be 5, and that is to multiply to y is to negative 15 plus 21. All right, and we know that negative 15 plus 21. So how we got 21 was because of the double negative signs or minus and negative. So we know that negative 15 plus 21 is going to be positive 6. Yes. So I'm just going to remove this expression right here and write positive 6. So which means your final result will be x to the 5th power and y to the 6th power. This is very good. Thank you for joining my lesson, and I will see you next time.